This is part 3 of problem 2.5 in the Did I Get This for Calculus 1. This is about figuring out applications of the intermediate value theorem. It's written here for our reference, and let's read it the way we should read theorems. If, all right, that means these are things that have to be true for the theorem to be usable. So we've got an if f is continuous on the closed interval, okay? So we need the function to be continuous on the interval we're talking about. And k is any number between f of a and f of b, okay? So that means, let's see, f of a and f of b are the values of the endpoints. A and b are the endpoints of the interval. F of a and f of b are the values of the function at the endpoints. So nk is any number between. Okay, so we have to be between the value at the left endpoint and the value at the right endpoint. And then we're done with the if, right? We have two things, the continuous on the closed interval that we need to confirm, and the k is somewhere between the function evaluated at a and evaluated at b. If those two things are confirmed, then we know there's a c, so that f of c is k. In other words, to speak in sort of technical language, there's a value that's the inverse applied to k, the inverse of the function applied to k. We can find a value that goes to the k if the k is in between the minimum and the maximum. If the k is between f of a, f of the left endpoint, and f of the right endpoint. So now we apply. For which functions can the intermediate value be applied? Oh, so we just need to confirm 1 and confirm 2 using a equals 0 and b equals 4. So we can just go through, right? We just have to confirm rule 1 and rule 2 for each one of these. So let's look at part A. Can we confirm it's continuous on the interval 0, 4? And of course the answer is no, because that means it's got some craziness. It's not defined at x equals 2. So no, rule 1 is not fulfilled. B, rule 1 is still not fulfilled, right? When you plug in a 2, I don't care what the top is, the bottom 0 function does not exist. So it's not continuous. C, -2 is the part that messes it up. -2 is the only way for this function to get discontinuous, to be not defined. So now what we want to do is go, okay, it is continuous on the interval 0 to 4. Nothing else weird happens because there's no square roots of negatives to avoid. Then we have to go to rule 2 to show, right, and k is any number between f of a and f of b. So what's the k that they're looking for? For which functions can the intermediate value theorem be applied to show that the function, has a 0, right? Having a 0, right? That means the 0 is our goal. We're trying to find the c that goes to 0. We're trying to find f of c equals 0. That's what has a 0 means. So, okay, f of c is going to be 0, but only if rule 2 is fulfilled. Rule 2 is that c is that k, which is 0, if there's a 0 between f of a and f of b. Oh, so we need f of a and f of b to have 0 between them. So let's figure out f of a and also figure out f of b. Well, f of a is 0, and figure out f of b. B is 4. And let's see what they are for this function in part C. Well, I plug in 0, I get -10 over 2, so I have a -5 here. You can do this on your calculator or do it as side arithmetic. I'll just speak it quickly. You confirm that I've done it right by double checking. F of 4, 4 squared minus 10 is the top. So 6 on the top. and 4 plus 2, 6 on the bottom. Oh, 1. So it goes from -5 at f of 0, and there's a value of 1 at f of 4. So 0 is in between those values. There is, right? We have from -5 to 1, and 0 is in between there. Yep. So that is a good. So C does have some value that reaches 0 somewhere between 0 and -4. Well, let's go for D, right? Same reasoning as C, we have nice continuity. This thing only messes up where x is -2, which is outside of our interval of concern. And then we just have to figure out f of 0, which is 10 over 2. That would be +5. And f of 4, 16 plus 10 is 26 over 6. 26 over 6, you know, 4 1/3. Uh-oh. We don't know if we include 0. I mean, 0 is not in that interval between 5 and 4 1/3, so that's a no. We cannot apply the theorem. Now, let me make a point here. Just because the theorem cannot be applied doesn't mean that it's impossible for there to be a value that is a 0 of the function. It just means the intermediate value theorem is not the way you'll be able to find one. There might be other ways, or there might be none. So there might still be zeros. It's just if there are, you're not going to find them with the immediate value theorem, because it requires to find a 0 something negative and something positive, so we can know that 0 is in between them. That's part 2. So part E, all right, it's a polynomial, so it's continuous. That's not even a question. And then let's plug in 0 and 4. Plugging in the 0 is easy. You get 16. Plugging in the 4 is going to be a little bit harder. 64 minus 32 plus 16. Looks like a 48 to me. So nope, 0 is not between 16 and 48. On to the next one. Yes, of course it is. Use your calculator to plug in the 4 and plug in the 0. Well, the 0 is easy. Plug in the 4 also and see what you get. I think you get 16. Let me double check that, please. 64 minus 32 minus, yeah, you get 16 as f of 4 and -16 f of 0, so that's a yes. That one does fulfill the 2 criteria for the intermediate value theorem. I think I'll stop here. Every one of these is just a matter of doing the same thing. Let me take a look at these things over here. Any other tricks? Exponentials are always continuous, so that's check and check. It's just going to be a matter of, oh, exponentials are always positive, no matter what. Any power is positive, so you're always going to be no for those. The logarithm of x plus a half, the logarithm of x minus a half. Let's see, logarithms can't be done on negative numbers. So if you plugged in your value of x equals 0 here, you'd get logarithm of a negative, which breaks, so it's not continuous on that interval. This one is continuous. The logarithm doesn't break when you're evaluating something 0 or above. Minimum value x of 0 starts with log of a half, and we go all the way up to log of 4 1/2. That's fine, that's continuous. But we do have to check the log of a half and the log of 4 1/2 and see if we get a positive and a negative. So I'll leave that to you. Check part 2 to see if you get a positive and a negative and therefore have 0. The final one, log of x plus 2 minus log of 4. This one is also good because a minimum of 0 for the x, log of 2 works. a maximum of 4 for the x, log of 6 also works. So it is continuous on the interval. And then again, I will let you do the computation to see whether or not we have a negative and a positive at the endpoints. If we do, then we know 0 is in between. If we don't, we can't use the intermediate value theorem. So there might be a 0, there might not, but we can't use the intermediate value theorem. So there you go. I'll leave the details of a couple of these to you.